Yes, so these are the three questions which I'm referring to. This is first, second, and third. All right, so this is especially from 3D geometry. So every day I am searching those questions which we haven't covered in our regular classes. So these three are really good. I like these questions. These are previous year's board exam questions which we haven't covered. So the questions are as follows. You're given two lines here. This is the first line. R1 is given to us and R2 is given to us. These are the two lines. You're asked to show that two lines intersect. All right, and find their point of intersection. That's the first question. Second question, you're asked to show that two lines are coplanar. There is one coplanarity condition which we have studied. If you forget that coplanarity condition, what do you do? So we'll also look into that. And find the distance of the point from 1, minus 2, 3 from the plane this measured parallel to the line. So this is not a regular distance. So it's a different kind of a distance. I think we have done a question of this type. But in any case, let's see. Let's go ahead and solve these three questions. So the first question is, show that the lines intersect. So the first line is I plus j minus k minus lambda times 3i minus j. And the second line is 4i minus k plus a constant mu. Okay, this is plus, right? So mu times 2i plus 3k. So how do you say, students, I want to know, how do you say that two lines intersect? Or what is that condition we use to say that two lines intersect? Any idea?
Sir, they'll have a common solution.
They have a common solution, yes. But a common solution, how do you find those solutions? What is the way? How do you find the common solution between these two?
Sir, parameterize both the lines in terms of one variable and then equate them to find that common point.
All right. So the second part of the question says you're also supposed to find point of intersection. So that's the second part. Or you can also think in a different sense. If you're only asked to find, or if you're only asked to see if the lines intersect or not, what are you supposed to do? See, imagine, these two lines, they have two different direction ratios, right? The direction ratios are not proportional to each other. 3i minus j and 2i plus 3k, right? These two are separate. Separate as in they are not same. We call this as B1. We call this as B2. These two are two different lines with different direction ratios. So there is a possibility that these two lines will be skewed lines, right? In fact, they are skewed lines. Now, if you show that the distance between these two skewed lines is 0, if you show that this distance between two skewed lines is 0, then it has to intersect. Correct? Does that make sense, students?
Yes, sir.
If you show, I'm only talking about the condition. I'm not telling anything about point of intersection. So if you ask me what is the condition for two lines to intersect is, can someone recall that numerator of skewed lines ka formula? Distance between, can someone recall that formula, students? Distance between two skewed lines is 0. Now, if I call this first point as A1 vector, and if I call this as A2 vector, then what is the distance between two skewed lines? It is given by A2 minus A1's projection on B1 cross B2. B1 cross B2 divided this magnitude of B1 cross B2. All right. So this is the formula for the distance between two skew lines. And if you show that this distance is 0, or in other words, if you show that the numerator itself is 0, then for sure these two lines will intersect. So let's look at the condition now. Now from these two lines, a2 minus a1 vector is given by 3i minus j minus k minus, okay, that's 0. So this is a2 minus a1. Vector b1 is 3i minus j. You can see what's happening here, students. b2 is 2i plus 3k. Now, if you have to show this distance is 0, then what are you supposed to do? You have to see a2 minus a1 dot product with b1 cross b2. And that's given by the determinant of a2 minus a1. That's 3 minus 1, 0, 3 minus 1, 0. And this is 2, 0, and 3. Right here, the first row is components of a2 minus a1. Second row is components of b1. Third row is components of b2. And determinant by two rows are equal, so it has to be 0. So what did we prove? We have proved that these two lines intersect. This is the first part. All right. Now this qualifies as a 3 marker. All right. If you're asked to find point of intersection, as Manish pointed out, we have to solve both the line equations. So if the first line equation is given by I plus j minus k plus lambda times 3i minus j, second line is 4i minus k, 4i minus k plus some other constant mu times 2i plus 3k. Now, how do you solve these lines? It's always better you write it in the Cartesian form and solve the equations. The Cartesian form for the first line is x minus 1 by 3, y minus 1 by minus 1, z plus 1 by 0. Now, how did I write this? The first line passes through 1, 1, minus 1, which has direction ratios 3, minus 1, 0. The second line, on the other hand, passes through 4, 0, minus 1, and has direction ratios 2, 0, 3. So let me write down the second equation. X minus 4 by 2, y minus 0 by 0, z plus 1 by 3. So these are the two lines. Equate the first one to lambda, equate the second to another constant mu. Now from the first case, you can write line 1. The general coordinate on line 1 is 3 lambda plus 1. Y is 1 minus lambda. Z is lambda minus 1. Okay, 0 minus 1. Alright. And for line 2, the general coordinate is x is 2 mu plus 4. Y is 0. And Z is 3 mu minus 1. If two lines intersect, students, both their general points have to be same. So what do we get? We get three such equations. We get 3 lambda plus 1 to be equal to 2 mu plus 4. That means the general coordinates, the x coordinates I'm equating. At the same time, I'm equating the y coordinates. At the same time, I'm equating the z coordinates. 3 mu minus 1 is minus 1. So in this case, lambda is turning out to be 1. And here mu is turning out to be 0. If lambda is 1, mu is 0, you have to also see if this is getting satisfied. If I put lambda as 1, I get 3 times 1 plus 1. And what is mu? Mu is 0. 2 times 0 plus 4. Both these left hand sides and right hand sides are equal. So this will only happen if both lines intersect. If both lines don't intersect, whatever value of lambda and mu you get, it might not satisfy the third equation. So you might end up in that case. So the point of intersection will be 3 lambda plus 1, which is 3 times 1 plus 1, that's 4, y coordinate is 0 and z coordinate is -1. So this is the point of intersection of two lines, students. Is this clear? All right, so the gist of this problem is this. First things first, if you're asked to see two lines are intersecting, ensure that the skew line's distance between these given two lines is 0. That's the condition. If you want to find point of intersection, find out the general coordinate on each of the lines, equate all the respective coordinates. Coming to the second question. Control C, just a minute. You're asked to show that the lines are coplanar. How do you show the lines are coplanar? Anyone? Anyone, students? How do you show that the lines are coplanar? Anyone? Students, please let me know. How do you show lines are coplanar? Okay, again, someone says scalar triple product. Yes, absolutely. You see, if you look at the first question, if you look at the first question, it says you're asked to see if the lines intersect. All right. Now that is almost same as saying the lines are coplanar, right? If two lines intersect, these two lines intersect along a plane. Two lines will intersect always along a plane. So here, the second question is also same as the first question. So if two lines are coplanar, then what does it mean? And you can look at the direction ratios and figure out. Direction ratios are 2, 4, -1, 3, -2, and 1, right? They have different direction ratios. So if you want to prove that two lines with different direction ratios lie on a plane, it means they should intersect. There's no other way. All right. So just a minute. So what are we supposed to write here? The condition here, again, the condition of coplanarity is to prove that the skew line's distance between these two is 0. All right. Always remember, you take any two parallel lines, students, in 3 dimensions. In 3 dimensions, you take any two parallel lines. Parallel lines always form a plane. You can always find a plane passing through these parallel lines. You take any parallel lines in 3-dimensional space, there will be a unique plane which passes through these two planes. So if you are taking two skew lines, and if you're asked to see if they are coplanar, it means they should intersect. Only then they will be coplanar, right? So the condition here is, again, to show that the distance A2 minus A1 dot product with B1 cross B2 upon its magnitude. We're asked to show that this is 0, or just show that A2 minus A1, the scalar triple product, B1 cross B2 is 0. Again, here A1 vector is I 3j 0k, and A2 vector is 4i plus j plus k. And from these two, A2 minus A1 vector, let's see what happens. A2 minus A1 will be 3i minus 2j plus k. Okay, we got A2 minus A1. Let's write on B1 vector. B1 is 2, 4, and -1. So let's write it in the vector form 2i, 4j minus k. And B2 vector is 3i minus 2j plus k. Notice that A2 minus A1 and B2 both are same. Both are same. then their determinant will be 0. Determinant as in the scalar triple product का determinant B1 cross B2. There is one query in the chat box. Let me see. So even when they don't intersect but have proportional direction ratios, they are coplanar. Absolutely. When you say two lines have proportional direction ratios, they are parallel. They are parallel to each other. All right. So again, when it comes to parallel lines, they will always form a plane. In our case, a2 minus a1 is 3 minus 2, 1. 2, 4, minus 1, 3, minus 2, 1. And clearly this determinant is 0 because first and third rows are same. So we have proved that lines are coplanar. Lines, they form a plane. First point. Second is to find the equation of plane containing these lines. So let me draw a simple figure. All right, this is the plane. And then imagine there are two lines. First is this line. All right. Second is the another line. Let me use a different color. Imagine this is the other line. Fine. The first line is x minus 1 minus 3, x minus 1 by 3, y minus 3 by 4, z by minus 1. This is the first line. Let me call this L1. L2 is x minus 4 by 3, y minus 1 by minus 2, z minus 1 by 1. Two lines are given. You are asked to find the equation of the plane. See, it is clear that the first line passes through 1, minus 3 and 0, correct? It passes through 1 plus 3. Okay, it's plus 3 and then 0. Of course, the second line passes through some other point. Let me put it here, which is 4, 1 and 1. Now you see, if I have to write equation of plane, I need to equation of plane. I need to have a point through which it passes. So equation of plane passing through, let me write one point. Let me take 1, 3, 0. This plane passes through 1, 3, 0. And let's say, let the normal be AI, BJ and CK. This ABCs, capital ABCs are the direction ratios of the normal to the plane. Can someone tell me how do we find the direction ratios of the normal to the plane? Anyone, students?
So the cross of the direction ratios of the lines.
Absolutely. So you see these two lines are on the plane. So if you have to find out the perpendicular of the, let me write down this. This is the normal. So call this as n. So if you have to find out this normal, this normal is nothing but the cross product of direction ratios of the line. All right. So B1 has components 3, 4 and minus 1. Let me write down directly I, J. Components of B1 are 3, 4, minus 1. What are the components of B2? 3, minus 2 and 1. Okay, so I times 4 minus 2 is 2 minus J times 3 plus 3 is 6. K times minus 6 minus 12, that's minus 18. So you see, this is 2i minus 6j minus 18k, and this is our normal vector. So I can clearly say A is, okay, I'll write it as A, B, C, which are the normal to the planes as 2, minus 6 and minus 18. Excuse me for that, students. So equation of the plane. equation of the plane will simply be a times x minus x1 plus b times y minus y1 plus c times z minus z1 to be equal to 0, and the values of a, b, c will be 2 times x minus x1. What is x1, y1, z1? It is precisely the point 130. 2 times x minus 1 plus minus times y minus 3 minus 18 times z minus 0. Okay, so this simplifies to 2x minus 6y minus 18z. And what are the constant terms? Minus 2 plus 18, that's 16. And you can take out a factor of 2. So that gives you x plus x minus 3y minus 9z plus 8 is 0. This is the equation of the plane, students. So what all did we do here is, first things first, we have proved that two lines are coplanar using the skew line square distance formula. First point. Next is to find out the equation of a plane. We took one point on the plane and we have found out the normal to the plane. How did we find normal to the plane? It is got by cross product of two lines. That's the idea here. And the third question, I will leave this third question to you to do, students. Please give it a try. I'll draw the diagram for you. Any doubts up to this point, student? Any doubts? All right, third question ka solution now. As I said, only I'll help you, not the solution. So you have a plane, some plane, and you're asked to find the distance of the point 1, minus 2, and 3. Okay, there's a point 1, minus 2, and 3. Distance of the point from the plane, call this plane as x minus y plus z is equal to 5, measured parallel to the line. So usually when we talk about distance, we generally talk about perpendicular distance. But here, they've asked us to find the distance from this point all the way up to the plane, measured in some other direction, parallel to another line, it seems. So what is that line? Let me draw another line. Let me choose another color. Okay. So there is a line parallel. Oops. So there is a line parallel to this, which is like this. Let's draw it clearly. This is the line. Let me give it some 3D effect. Okay. And this is given by x plus 1 by 2, y plus 3 by 3, z plus 1 by minus 6. You're asked to find this distance d. All right, students. So call this as p, call this as q. Question is to find distance pq. All right, students. So how do we do this? Can anyone help me out with this? Two lines are parallel to each other. Anyone? How do we measure the distance? PQ?
Sir, we'll take a line that has the same direction ratios as the other line they've given and passing through point 1, 2, 3. So you get the equation of the line.
You mean to say the line equation PQ, right? So you first write equation of PQ. So what is the equation of PQ? Since both are parallel to each other, I can directly write equation of line x minus 1 by 2. Okay, where did I get this 2 from? 2. Okay, this 2 is 2, 3, and minus 6. These are the direction ratios, right? So I'm copying these direction ratios here. X minus 1 by 2. The second is y plus 2 by 3. This is z minus 3 by minus 6. So these three are the direction ratios, 2, 3, minus 6. The point is 1, minus 2, and 3. Now, once you get the line equation PQ, you're almost done with the problem. How? Now, this line cuts the plane at Q. So find the general coordinate on this line PQ and ensure that this general coordinate lies on the plane. So x is equal to 2 lambda plus 1, y is 3 lambda minus 2, z is 3 minus 6 lambda. So we want this general coordinate to lie on the plane. So 2 lambda plus 1. I'm substituting this. Let me put an arrow mark here. Right, I'm using this in this. Look at the hash mark, students. 2 lambda plus 1 minus 3 lambda minus 2 plus 3 minus 6 lambda should be equal to 5. Okay, so what is the value of lambda? 2 minus 3 is minus 1, minus 1 minus 6 is minus 7 lambda. 1 plus 2, 3, 3 plus 3, 6. Okay, that's minus 1. Is lambda 1 by 7, students? Please help me out. Is this correct? Help me out with this, students. So we took the general point on the equation of line. We have substituted it in the plane equation and we got the value of lambda. Now once you get the lambda, substitute this lambda. So the coordinates q will be 2 lambda plus 1, that's the x coordinate, 3 lambda minus 2, that's y coordinate, and z coordinate is 3 minus 6 lambda. So the coordinates will be 9 upon 7 and minus 11 upon 7. Next is 15 by 7. That's it, students. You got P and Q. Find the distance PQ. B is PQ. All right. So 9 by 7 minus 11 by 7, 15 by 7 is the coordinate of Q. Once you know the coordinate of Q, find out the distance. That's the problem. So here, what is the crux of this problem? The crux of this problem is find out the equation PQ. Once you find out the equation of PQ, find out the general point and ensure that this general point is on the plane, get the value of lambda, get the coordinate, and find out the distance. This qualifies to be a 5 marker. Any doubts in this? Let me write it down. Find the distance.